This is pre-AP Pre-Calculus. We're doing notes, chapter 11. This is the first section of that chapter. We're examining periodic functions and their properties, and we are going to look at this graphically and numerically. First, some terms. Periodic function, a function that returns to the same value at regular intervals. In other words, the graph repeats itself. So let's take a gander at this little fellow right here. I think we would agree that this graph, this is the unique part, and then it repeats itself over and over and over and over and over. We would call this part right here one cycle. I could take that cycle and copy it and paste it, and I could find myself with many cycles. Period. The distance along the horizontal axis the function must travel before it starts to repeat itself. Looking at this example here, I have just outlined one cycle. What is the distance from here to here of this cycle, the horizontal distance? Well, we got 1, 2, 3, 4. We went 4 units. So we would say the period is 4. We're going to actually do this example in a moment. I'm just trying to get you to understand these terms. So for a period, if you wanted a formula for period, you could say that the period is going to be x sub the end of a cycle minus x sub the beginning of a cycle. This referring to one cycle. It doesn't matter where you choose that cycle. So for example, if I go from -3 to 1, 1 minus -3 is 4. If someone else says, well, I want to go from 1 to 5, 5 minus 1 is still 4. It doesn't matter which cycle you choose. You could also look at this and say, well, when I saw this, I saw the cycle as being like this. Well, that's true also. There's no defined start of a cycle, because I could take this and I could copy and paste it and repeat itself over and over. You just pick a convenient point to start, and that will dictate where the cycle ends. So if you wanted a formula for how to find the length of the period, take the end of a cycle minus the beginning of the cycle, and that will give you the period length. It is a horizontal distance. Amplitude. The height from the midline of a function to its maximum and minimum value. Well, I haven't really said what a midline was. In this picture here, which once again we're going to be doing formally, just trying to get you to understand what's going on right now. The midline is going to be halfway between the top and bottom, the highest and lowest parts of this graph. So for example, this goes as high as 3 and it goes as low as -3. So halfway between is going to be here at 0. This would be the midline. Telling you what the midline of this is because we're defining amplitude by using the midline. The height from the midline of the function to its maximum or minimum value. So once you know where the midline is, you just go up till you get to the top, that's 3 units, or you go down till you get to the bottom, that's 3 units. The amplitude of this function would be 3. Once again, we'll do this problem formally here in a moment. If you wanted a formula for amplitude, here's the formula that you could use if you're into formulas. The amplitude is going to equal the y max minus, I said minus instead of minus, minus the y max, I wrote max twice, minus the y min, and you divide that by 2. So in this case down here, 3 minus a -3, that's 6. Divide that by 2, you get 3. It's because the amplitude for this is in fact 3. All right, let's check out this example. Question 1, we have this graph and we have a bunch of questions relating to it. So we're going to add some things to this picture and I would encourage you to do as well. First of all, is this function periodic? If it isn't, give us a reason. If it is, we'll just say that it is. A periodic function, once again, is a function that returns to the same value at regular intervals. In other words, the graph repeats itself. This is definitely periodic. Here's a cycle, and then it repeats. It's identical. And then it repeats. It's identical. So yes, this is a periodic function. Don't have to give a reason why if it's yes. What's the domain of this function? Well, it's implied, since this graph goes all the way to the end of this coordinate plane that you see here, that this is going to go forever left and right. So the domain for this, we could say negative infinity to infinity, or we could say all real numbers. What's the range? Well, that's how high up or down this graph goes. It goes as low as -3, goes as high as 3, and everything between it is included. So the range, we're going to say, goes from -3 to +3 inclusive. But what's the period length? Well, the period length is the horizontal length of one complete cycle. So once again, I'm going to trace over one cycle. So the distance from one peak to another is 4 units. If you want a formula for this, the period, once again, is the x sub end of the period minus x sub beginning. I said period, I mean cycle. This is one cycle. So if you chose the cycle that I had outlined there, the end of the cycle is at 1, subtract from that. The beginning of the cycle is -3, and that's how we would get 4. You do not have to show that work unless the directions explicitly ask you to. What's the amplitude? The amplitude is the distance from the midline. We should probably answer that first. Where is the midline? The midline, I'm going to draw it here, is a line that's halfway between the highest and lowest points on this graph. The midline is always y equals a number. In this case, it's y equals 0. The amplitude goes 3 up from that and 3 down from that. We would say the amplitude is simply 3. If you wanted a formula for amplitude, it's y max, I said it again, minus y min divided by 2. Our y max is 3, our y min is -3. That's going to be 6 over 2, which is 3. You don't have to show that work unless you're asked to, and I likely won't ask you to. So that completes one example of a periodic function answering these questions. Let's check out another. Is this graph a periodic function? Well, it sure looks like it. If I were to trace over, let's say this right here, I could take this and copy it and paste it, and that would be this function continuing. We're assuming that as it goes off the coordinate plane, it's going to continue with the same way that it's going. So we would say, yes, it's periodic. What's the domain? This looks like it's going left and right forever with no points missing. It's continuous. So it's all real numbers, or we could say negative infinity to infinity. What is the range for this? What goes as low as -2, and it goes as high as +2. And it includes those numbers. So we say the range is -2 to 2 inclusive. For me, it's an optical illusion. It appears as though much more of the graph is above the y-axis than is below it. But it isn't. It goes as high as 2 and as low as 2. I don't know why, but that illusion is real for me. What's the period? Well, that is the horizontal length of a cycle. I'm going to choose this to be my cycle. It's more definitive for my eyes. So the period is going to go from -2 to 4. That distance is 6. So the period is 6. If you wanted to write the formula that we talked about earlier and plug numbers in, that's cool too. What's the amplitude? Well, if you take the highest point minus the lowest point, that distance is 4. You cut that in half, that gives you the amplitude. The midline is halfway between the highest and lowest points. it's usually a good idea to identify your midline graphically. That looks like it's at y equals 0. If you wanted to mark up this picture a little bit to try to add some of this stuff to it, midline is clearly there. This is the amplitude. And this is the period length. If that's helpful, add it to the picture. If it isn't, then don't. Number 3, is this periodic? It is not. Now, does this have a pattern? Yeah. Does the pattern really repeat itself? It really doesn't. This starts here at 0, it goes down to -2, up to 1, down to -3, up to +3, down to -4, up to +5. We could use this graph to predict things, but the y values continue to get bigger as you go left and as you go to the right from the left. It's really not repeating itself. Well, is it a periodic function? I'm going to say no, because it isn't. And my reason, I'm going to say the graph's range continues to increase. I don't want to say range, that implies the entire thing. I will say the graph's height. Let's do that. Continues to increase. There's other reasons you could give as well. If possible, state the following. What's the domain of this? Well, this is going left and right forever, and there are no discontinuities, so this is all real numbers. This range, now it appears as though this range is finite, but if this continues to increase up and down, this range is going to go from -infinity to infinity, so it's also all real numbers. What's a period length? Well, that's a term that only applies to periodic functions. This is not. What's the amplitude? That's a term that only applies to periodic functions. This is not. What's the midline? I don't even think we could say what the midline is. Let's not. That only applies to periodic functions. Number 4, is this periodic? Well, let's examine this closer. There is a vertical asymptote here at -4. There's a vertical asymptote here at -1. And then between them, there is this curve. If I were to take this and copy it and paste it, could I contain this entire graph through this copying and pasting? Sure looks like it. So this is a periodic function. What is the domain? Now this gets a little tricky for this one because of these vertical asymptotes. Let's just assume it's everything. All real numbers. That's not entirely true because every time there's a vertical asymptote, there are no x values there. So we have to get rid of those somehow. To get rid of those, so we're going to say it's all real numbers except, now I'd like to say except the vertical asymptotes, but that doesn't tell the reader where those are located. You pick the location of one vertical asymptote. So one of those, for example, is 2. I'm just going to pick the first positive one. Now, if I just say except 2, then that only means I'm not using this number. What about all these other ones? Well, how far apart are these from each other? They are 3 units apart. Every set of vertical asymptotes are 3 units apart. So I could say except for 2 plus 3 times n, and have to define what n is, where n is an element of the integers. This is saying that n has to be an integer. N is an element of the integers. So does that cover all these? Well, let's check. If I put -4, would that fit in here somehow? Well, if I said n was -2, 3 times -2 is -6, plus 2 is -4. That covers this. How about -1? If I say n is -1, -1 times 3 is -1. There's -3, plus 2 is -1. This covers everything. Once again, this 2 that you see here is any vertical asymptote, and then the 3 represents the period length. What's the range for this? Well, this goes up and down forever, so we could say it's all real numbers. What's a period? As we've already mentioned, that is 3. Because if you go from any pair of vertical asymptotes, that period is going to be 3. Amplitude, this does not have an amplitude. Even though it's a periodic function, there's no amplitude because the amplitude was defined as the height from the midline of the function to its maximum or minimum values. This doesn't have a maximum or minimum. It goes up and down forever. What's the location of the midline for this little fella? It is, once again, y equals 0. It will not always be y equals 0. Number 5. This one's a little cray-cray as well. Is it periodic? Well, let's see. If I take an open circle and a segment and another segment, if I were to copy that and paste it, could I get the rest of this graph? And the answer is for sure. So yes, this is a periodic function. What's the domain? Well, it's all real numbers except for the locations of these holes. So I'm going to say all real numbers except, pick a location of one of the holes. I'll pick the first positive one. You could pick -3, you could pick 1, you could pick 5, you can pick whatever you want. I'm going to choose 1. Plus, how far apart are each of these holes? 1, 2, 3, they're 4 apart. So plus 4 times n, I have to define n, where n is an integer. What's the range for this function? It goes as low as -2, but it includes it. And it goes as high as 4, but it does not include 4 because there's an open circle at 4. What's the period? The period is the horizontal length of one cycle. And this period is going to go from -3 to 1 before it repeats itself. So we would say that period is 4 in length. What's the amplitude? That's the distance from the midline to the height, or you could say it is the top minus the bottom cut in half. So if we take 4 minus a -2, that's 6. Cut that in half, that would make the amplitude 3. The midline's halfway between the top and the bottom. So I would say the midline is here at y equals 1. I recommend not doing this in the order that I just did it. Writing the midline first is a good idea. It makes the amplitude more obvious. We're going up 3, down 3 for the amplitude. Now you might be saying, well, that doesn't really make a lot of sense for the amplitude because this up here is going to an open circle. It doesn't include it. That is true. But it does include this bottom number. So we could say it goes down to the minimum 3 units. So I'm pretty sure that the amplitude is 3 for this, with a tiny question mark, because the more I think of it, maybe that's not entirely true, but for now, let's say that it is. With me, oops, I miswrote something here. I said this is y is 1, and I wrote y is 0. So y is 1. But this leaves the door open for me to come back later and say, you know what? I was wrong about that. 6. The table below shows values of one cycle of a periodic function. The graph of f of x consists of straight line segments that connect the consecutive points in the table. Based upon the values in the table, we'll explain how you know this is one cycle of a continuous periodic function. Well, we're told it's one cycle up here, so that's why I know that it is. But it says based upon the table. If we only had the table, I would assume that this was one cycle, but I wouldn't know it for sure. So I'm going to say that. I am assuming the table is one cycle. Now, why could I assume that? That's because f of x is equal to the same value at x equals -4 and x equals 3. At -4, it's equal to 4, and at +3, it's equal to 4. So I'm assuming this is the beginning of a cycle, this is the end of a cycle, then it repeats itself. B, identify the period and amplitude of this function. Well, if I wanted to follow my formulas, which you don't have to, for the period length, I'm going to take the end of the period minus the beginning of the period. The end of the period, these are x values, is 3. The beginning is -4. So we're saying the period length is 7. For the amplitude, if I was going to use this formula, I would say it's the maximum value for y, subtract the minimum value for y, and then divide that by 2. Biggest value for y here I see is 4. Smallest value for y I see is -2. So that's 6/2. So we're thinking the amplitude for this is going to be 3. Once we see the picture, that'll be obvious to you. C, sketch the graph of f of x on the interval from -11 to 10 inclusive. So I'm going to take the ordered pairs that I have. I'm going to put them on here. So we got -4, 4. Let me make that larger. 0, 2. 1, -2. And then 3, +4. The direction said that these consist of segments that go from one of these points to the other. Now we're supposed to graph this for as far as we can go on this graph from -11 to 10. So how do we do that? Now I could easily just take this and I could just copy it and paste it like so. Be done with it. And you can see that's how this graph is. That is not that helpful for you who does not have an iPad. So here's what we'll do. We'll take every point that you see here, and we will move one period left or right to put the next point on. Since the period for this is 7, if I take this point, for example, and I go 7 units to the left, 1, 2, 3, 4, 5, 6, 7, there should be a dot there. If I go here and go 7 units to the right, 1, 2, 3, 4, 5, 6, 7, there should be a dot there, which there is. If I go 7 more, it's going to put me at 10. There should be a dot there. I can use that same logic for this point here at 0, 2. If I go 7 units to the right, put a dot. If I go 7 units to the left and put a dot, these should be points on my graph. If I go down here at 1, -2, and if I go 7 units to the right, I'm going to be at 8, -2. If I go 7 units to the left, I'm going to be at -6, -2. If I connect these points, using a straight edge preferably, this should look the same as we continue. I'm just going to highlight this is one cycle. D, what are the values of f of 15 and f of -77? Show your work. That doesn't mean that we are going to sit here and draw this out all the way to 15. It's not very far. And all the way to -77. That's real far. Here's what we're going to do. This is extremely similar to us talking about coterminal angles. If you remember when we were doing trig functions, we were trying to find coterminal angles. Coterminal angles were complete revolutions apart from each other. So if we had like 390 degrees, and we wanted to find a coterminal angle between 0 and 360, we subtracted a complete revolution, 360, and we got 30 degrees. This is the same concept. So let me try to explain this slowly, and then I will show you how you can do the work a little differently. F of 15. Is f of 15 show up in this? It does not. What I would like is I'm going to change what my cycle is here. I'm going to say that this is my cycle right now. I would like a number instead of 15, a number to fall between the first cycle, between 0 and 7. 15 clearly doesn't. So if I subtract a cycle from this, or a complete revolution, I can try to get this down so how it would be in this first cycle. So here's what I mean. I'm going to take the number 7 and add it as many times as I have to till I get to 15. 7 plus 7 is 14. That's 2 cycles. And if I add a 1 to that, that's equivalent to 15. 7 plus 7 plus 1 is 15. The 7 and the 7 don't do anything. That puts you right in the back in the same spot. It's this 1 that takes you someplace. This is equivalent to f of 1. So if I look here on my first cycle, what is f of 1? It's negative 2. Therefore, f of 1 is negative 2. Let's try with the negative 77. It's a little bit different. I have to go in the negative direction. So just like you would do in with coterminal angles, sometimes you would subtract complete revolutions. So I'm going to go backwards, negative 7, negative 7. How many times am I going to do this? Until I get to 77, 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is ridiculous. So here's what that tells me. This is going to be the same location as negative 7, which is going to be here at 2. You could also say, well, that doesn't get me to 0. You could say then you could also add to this 0, because all these cycles cancel out. And you could say, well, that's the same place that you would be if you were at 0, which is also positive 2. So how could we write this simpler without doing all these calculations or writing all these 7s? Here's what you could do. This first one, we could say, well, I'm going to choose f, and I'm going to choose a multiple of 7 that's close to 15, such as 14. And then how many numbers do I have to add to that to get to 15? You get rid of your complete revolutions, your complete cycles, I should say, and you get f of 1, which is negative 2. For f of negative 7, well, f of negative 77, that's a complete cycle 11 times. Since it's a complete cycle, it's the same as being f of 0, which is 2. Before I do E, see if you can do this on your own. I would stop the video and see if this makes sense to you, and then try to do it. And we're back. F of 64, well, that I could say the closest multiple of 7, and I'm choosing 7 because that's the period length, is 63. And I need one more, so that means this is the same as f of 1. I'll look at my graph here in a second to see what that is. F of negative 25. If I'm doing multiples of 27, I could do this in a couple different ways, and it's going to work out either way. I could say negative 28, that's a multiple of 7, but I went too far. I need to get to 25, so I'm going to add 3 to this, which means this is equivalent to f of 3. So if I look here, what is f of 1? That's negative 2. What is f of 3? That is a positive 4. All right, hopefully that makes some sense. If I made some mistakes or if you got questions, please drop me an email, or better yet, send me something on Remind or Google Classroom. Peace.